Embedded software is now ubiquitous, powering everything from our cars and planes to medical devices and more. Over the past few decades, the complexity of this software has exploded, making the production of robust, secure embedded software applications increasingly challenging and expensive for businesses across many industries. As the demand for more sophisticated and reliable embedded systems grows, companies are seeking innovative solutions to streamline development processes and ensure high-quality outcomes. Many companies have turned to model-based design with Simulink to tackle the complexities of embedded software development. The MATLAB and Simulink tools offered by MathWorks enable engineers to create graphical models of embedded software that serve as executable specifications. This approach allows for early detection of design errors through simulation, significantly reducing the risk of costly mistakes later in the development process. Additionally, Simulink facilitates the automatic generation of C code from models, streamlining the transition from design to implementation. The Reactis family of tools offered by Reactis Systems supports a model-based design process, complementing the capabilities of MATLAB and Simulink. Reactis provides additional functionalities that enhance the model-based design workflow, such as the automatic generation of comprehensive yet compact test suites from Simulink models. These tests can help uncover runtime errors and check if a model satisfies its requirements. Reactis also facilitates testing whether C code conforms to the behavior specified by a model, a check sometimes called back-to-back testing. By integrating Reactis tools into their development processes, companies can achieve greater efficiency and reliability in their embedded software projects. Reactis Tester makes test suite generation straightforward. All you need to do is load your model into Reactis, and then select Test Suite followed by Create. As Tester runs, Reactis identifies coverage targets within your model. But what exactly are coverage targets? These are specific points in your model that need to be tested to ensure comprehensive coverage. This means you can have confidence that your model is being tested from every possible angle, giving you peace of mind and a robust test suite. Now that Reactis has identified the coverage targets, the next step is to select the inputs that will exercise as many of these targets as possible. This is where Reactis truly shines. By intelligently selecting inputs, Reactis ensures that your model is subjected to a wide range of scenarios. This not only helps in identifying potential issues but also strengthens the overall reliability of your model. With Reactis, you can be sure that your test suite is both comprehensive and effective. Reactis also detects potential runtime errors. As it constructs the tests, Reactis continuously monitors for any signs of trouble. If a runtime error is detected, Reactis will alert you immediately. With Reactis, you can stay ahead of the curve and ensure that your model is error-free. Reactis creates tests for either a complete Simulink model or for any subsystem within a model. In either case, the unit under test has a set of inputs and a set of outputs. As Reactis Tester builds a test, at every time step, Tester intelligently selects new inputs and computes new model outputs. Reactis then saves this information as a test. In essence, it creates an intelligent simulation run of your model. With Reactis, regression testing is easy. When you make changes to a model, it's important to know if the changes modify the externally visible behavior of your model. To answer this question with Reactis, generate tests from the original version of the model. Then, run those tests on the revised version. If any output produced by the revised model differs from the value stored in the test, which came from the original model, the difference will be flagged. A similar approach is possible for back-to-back testing. To check if a C program conforms to the behavior specified in a model, use Reactis Tester to generate tests from the model. Then run the tests on the C code to compare the outputs produced by the C code to those produced by the model and flag any differences. So far, we have focused on generating tests with Reactis Tester. A second component of Reactis is Reactis Simulator, a simulation environment for Simulink models. With Simulator you can run your tests interactively and observe how your model responds. After enabling Simulator and loading a test suite, simulation is managed from a simple set of controls in the toolbar. You can execute a single simulation step in which Reactis reads the inputs, executes the model, and updates the outputs. You can execute a block at a time. You can do a slow simulation in which blocks are highlighted as they execute. You can do a fast simulation in which Reactis executes the model but without animation. You can even perform reverse execution. So if you detect a problem you can go back in time to try to uncover the source of the problem. Simulator tracks the same coverage targets as Tester. When running a test, Simulator uses color to show which coverage targets have been exercised or covered, and which have not. These indicators help you understand how each test is affecting your model. You can then decide whether the model has been tested sufficiently, or if it needs more testing. Reactis Simulator can show you which switch block paths have been selected, which branches of relational operators have been taken, which stateflow states have been entered and which transitions have fired. Let's look at an example. Here we see indicators on a logical operator block. The red 1 and 0 indicate that the block has never evaluated to true or false. When the block output is true, the 1 changes to black. When it evaluates to false, the 0 changes to black. You can right-click on the output of a logical operator block to view the MCDC-related targets associated with the block. These and other visual indicators help you understand how comprehensive your tests are and whether they adequately exercise your model. In addition to the highlighting in the main diagram, coverage information can be obtained from the coverage summary dialog, which gives summary statistics, or from the coverage report browser, which gives a complete listing of the status of all coverage targets in the model. Reactis can also generate an HTML test execution report that lists any errors detected, any differences between the values stored in a test and those computed by the model, as well as detailed coverage information. In addition to tracking coverage, Simulator is also a fully functional debugging environment for models. Let's review some of the features. You can hover over any signal wire to see its current value, or open a scope to see the signal history, or add the signal to the list of watched variables. Data tracking works the same for stateflow variables. You can set breakpoints on any Simulink block, or stateflow state, or transition. You can highlight any signal to trace it through the different levels of the model. You can interactively construct a test by feeding in the inputs to drive a simulation. When you enter this mode of operation, you have a dialog which lists each input of the model. You then specify a value for each of the inputs. Then take a step which will use the values you've specified for the inputs. So far we've seen how Reactis can help test and debug Simulink and stateflow models. But what if your model contains C code in the form of S functions, C caller blocks, or stateflow custom code? The Reactis for C plugin integrates seamlessly with Reactis for Simulink to test models that contain C code. With the C plugin, Reactis Tester identifies and attempts to exercise coverage targets within any C code in your model. In Reactis Simulator, step from the model into the code, in order to visualize coverage tracking and inspect variable values. Similarly, if your model includes embedded MATLAB code within MATLAB function blocks or called from Stateflow, the Reactis for EML plugin supports whitebox testing of such models. So far, we have seen how Reactis Tester and Reactis Simulator support coverage-based testing to find runtime errors in models, perform regression testing, and check if C code behaves like a model. Reactis Validator is a third component of Reactis that helps you check whether a model violates its requirements. Validator lets you formulate model requirements and then performs an automated check for violations of a requirement by your model. If it finds a violation, it provides a test that demonstrates the problem. To see how Reactis Validator works, consider a requirement for an adaptive cruise control. The requirement says that the cruise control should remain inactive if the vehicle speed is low. We can add an assertion to check this requirement by right-clicking in the main Reactis panel, and then selecting Add Assertion, then Expression. In the resulting dialog, enter a name for the assertion. Then enter an expression that will be true as long as the requirement is not violated. Finally, click OK. The expression we entered has two variables, speed and active. We now need to specify which signals from the model should be used for these variables when evaluating the assertion. After adding the assertion to the model, we can launch Tester to search for violations. We see here that Tester has found violations for several user-defined assertions. Click Load and Close to load the test suite we just generated into Reactis Simulator. When we run the tests, our assertion is highlighted in red and yellow to indicate that it was violated. We can hover to see that it was violated in step 104 of test number 9. Select Run to Violation to load test 9 and run to step 104. If we back up to step 103, we see the assertion is not violated. We then retake the step and investigate the violation. We see that the cruise control is, in fact, active when the speed is less than 6 meters per second and therefore confirm that the requirement is violated in this test step. Let's trace the signal to diagnose the issue. The problem is that the logic to disable the cruise control at a low speed does so at 5 meters per second rather than 6 meters per second as specified by the requirement. To recap, we have seen how Reactis supports a model-based design process. Reactis Tester lets you generate comprehensive test suites from models that can help detect runtime errors, perform regression testing, and check if C code conforms to a model. Reactis Simulator is an advanced debug environment for Simulink models that lets you execute tests while tracking coverage and observing data values. Reverse execution helps to diagnose issues detected. Reactis Validator lets you formulate requirements your model should satisfy and then perform an automated search for violations. The net effect of using these tools is more robust embedded software at a lower cost. To learn more or request a free trial, please visit our website. Thank you.